some reason the video didn't work. Would have been a good one too. So this was glowing red hot. It's sitting at 1050 degrees. It's cooled down a little bit now to 581. I'm just kind of cooling it down. Hot air gets blowing out and the temperature starts to drop. The blades themselves now, or the blade, singular, is in here. So two big aluminium plates. When I took the blade out, it's actually bent a bit like a banana. Well, sideways, bananas are bent the other way. Anyway, it was bent. So I slapped it between these two big plates, put the clamps on. That brings the temperature right down and hopefully straightens it out. Well, I mean it's straight now. It should be straight when I take the plates off as well. So the other thing that happens is when you heat it up to the correct temperature, 1050 for this one, you change the structure of the lattice of the crystals, which is what metal is made out of. So change the shape, goes really brittle and hard, and then by cooling it down rapidly it can't change back to its more relaxed state, which is what annealed or soft metal is. It does one other thing though. This is a high alloy, high chromium steel. It's got about 13, maybe 14% chrome. And the temperature which I heated it at causes any chromium carbide to dissolve. Chromium carbide is big, really hard carbides. You think, oh, that's what I want in my blade. Actually, you don't. If you get a chip, it'll chip on the carbide and it'll go to the next carbide, and chain reaction, you get a big lump of metal coming out. So instead, what you do is you dissolve it. No carbides get a chance to form. No chromium carbide, which are big. Little carbides form, but not the big chromium ones. And that means your chrome is essentially not bound up. So it's what we call in solution, and that's why you get your corrosion resistance, because the chromium is not caught up in carbides, it's free in the steel, and it means that anytime you scratch your blade or bring it into contact with something, it oxidizes super quick, and that's what chromium does. It creates a shiny oxide on the outside. It's not actually rust proof, it's a super ruster, but it prevents normal sort of ferric, like prevents rust forming essentially, but it is a super oxidizer. And so yeah, that's why we keep it in solution, so that it can affect the blade and make it so that anytime you bump it or scratch it or cut something that's harder than the steel and it cuts into the metal, it oxidizes. You don't even see it, it's that fast, and that protects steel from getting any nasty rust on it. And that's how stainless steel works. Yeah. So anyway, it's in there now, it's cooling down. Well, it will be cool. Still slightly warm to the touch, and then I want to get that oven down to tempering heat. So either I'll just let it cool down and then put this in there, or I might just chuck this in the freezer and do it tomorrow. I haven't decided yet. So yeah, it's alright. I didn't have, once it started taking it out of the oven, I didn't get a chance to check whether the camera was going or not, and it wasn't. So there you go. You've always seen, brazen hot and a volcano and fire and gods of fire jumping up and down, but instead, you get to see a metal plate. Okay, cheers.